Good morning, grade 7 students. I hope you are all doing well. Today, we will continue chapter 1, covering the remaining activities on pages 10, 11, 12, and 13 in your book. Please open your book to page 10 and follow along as I explain. Activity 2, examining the shape of a solid. The materials used here: glass vessel, graduated cylinder with volume 50 ml, 100 ml beaker, a dice, and a stone. Procedure: place a dice in a glass vessel. Let's place the dice in the glass vessel. Then remove this dice and put it successively in a graduated cylinder and then in the beaker as shown in figure 1. In the first step, we put the dice in the glass vessel, then we remove it and put it in the graduated cylinder, and finally we put it in the beaker. Has the shape of the dice changed when placing it in the 3 different containers? What do you think? If we put it in the vessel, then remove it and put it inside the graduated cylinder and then in the beaker, do you think the shape of the dice changed? Of course, no. The shape of a solid is definite. Solids have definite shape, so their shape will never change when we put them in any kind of container. Using a stone instead of the dice, does the shape of the stone change upon repeating the same procedures if we use a stone instead of the dice? Does the shape of the stone change? Of course, no. Conclude. What characteristic can you give for the shape of a solid? We said that the shape of the solid is definite, so the shape of the solid will not change, so it's definite. If the shape of a solid influenced by the container it is put in, is the shape of a solid influenced by the container it is put in? No. So we conclude that the shape of a solid is definite and this shape will never be influenced by the shape of the container it is put in. Activity 3, measuring the volume of a solid. The materials used here are 3 graduated cylinders with different volume, 25, 50 and 100 ml. Water, dice and battery rod. Here we have three cylinders with different volume. The total volume here is 25, 50 and in the last one it's 100. Procedure: fill 3 graduated cylinders of different size with 20 ml of water. We fill the 3 graduated cylinders with the same amount or the same volume of water, which is 20 ml. Then bring a dice, drop it successively in each of the 3 cylinders and measure the rise in volume. Here the volume of the water is 20 and when we put the dice or when we drop the dice it becomes 24. Also here the volume was 20 and it increases and becomes 24 and the same in the last one, the rise in the volume is the same. So when we put the dice, the volume in the 3 graduated cylinders becomes 24. Are the 3 measurements of the rise in volume of water the same? Yes, it's the same. 24 here, 24 and 24. So the answer is yes. By dropping a battery rod instead of a dice, How do the measurements of the rise in volume of water differ? What do you think? If the volume of the battery is the same as the volume of the dice, so it doesn't differ, okay? So, the same. If the volume of the battery is equal to that of the dice, the volume will not change. It remains the same. What does the rise of volume in each container represent in the two cases? It represents what? It represents the volume of the solid which is dropped in the graduated cylinder. Conclude. Is the volume of a solid definite? First, let's measure together the volume of the solid here or the dice. Before we drop the dice, the volume V1 is 20. After we drop the dice, the volume V2 is 24. To find the volume of the dice, we subtract V2 minus V1, so 24 minus 20, the answer is 4 ml. So, the volume of the dice is 4. The same here, it's also the volume 4. So, this shows that the volume of the solid remains the same. So, solids have definite volume. Activity 4. Examining the shape of a liquid. The materials used here: 100 ml beaker, 100 ml graduated cylinder, Erlenmeyer flask, and colored water. Beaker, graduated cylinder, Erlenmeyer, and colored water. Procedure. Half filled a beaker with colored water. Transfer the water from the beaker to the graduated cylinder and then from the graduated cylinder to the Erlenmeyer flask. Look at the beaker. What's the shape of the liquid or the colored water inside the beaker? It's the same as the shape of the beaker. So, the colored water takes the shape of the beaker. When we transfer the colored water from the beaker to the graduated cylinder, the shape of the liquid takes the shape of the new container. Repeat the same procedure by using oil instead of water to fill the 3 different containers. We put oil in the beaker, transfer oil from the beaker to the graduated cylinder. What will happen to the shape of the oil? The shape of the oil will take the shape of the new container, which is the graduated cylinder. Compare the shape of water in the 3 containers. The shapes are different. Here, the shape of the colored water is the same as the shape of the cylinder. Here, it's the same as the shape of the new container, which is the Erlenmeyer flask. So, the shapes are different. Compare the shape of oil in the 3 containers. The same will happen. Oil takes the shape of the container. Conclude. Does a liquid have a definite shape? We said that liquid takes the shape of the container. So, liquids have indefinite shape. No, it has indefinite shape. What shape does a liquid take? It takes the shape of the container. Activity 5. Measuring the volume of a liquid. The materials used here are graduated cylinders of different sizes, 25, 50, and 100 ml, colored water solution, and alcohol. 3 graduated cylinders of different volumes, 25, 50, and 100. Measure 15 ml of colored water solution in a 25 ml cylinder. We put 15 ml of water in the first graduated cylinder. Then we transfer successively the above solution to different cylinders of different sizes as shown here. Record the volume reading in the different cylinders. When we put water in the first one, the volume is 15. Then when we transfer the colored water to the second beaker, the volume remains 15. And finally, in the last cylinder, the volume remains unchanged. So, how do the 3 measured volumes of water in the 3 different cylinders differ? The 3 volumes are the same, 15 ml. By repeating the same activity with alcohol, will the 3 volume of alcohol differ? Water is liquid and also alcohol is liquid. So, the same rule is applied here. So, the volume remains the same. Conclude. Does a specific amount of a liquid have variable volumes in different containers? No, because liquids have definite volume. So the answer is no, it has definite volume. Based on the previous slides, let's draw conclusion. Classification of matter. In activity 1, 9 objects are given containing different materials which are classified according to their physical properties. So we conclude that there are 3 basic states of matter: solid, liquid, or gas. And also we have a 4th state of matter that can exist at a very high temperature, and this state is called plasma. This is activity 1. We have solids, we have liquids, and we have the gas. In activity 2, the shape of a dice is examined, and in activity 3, the volume of the dice is measured. From these 2 activities, we find out that a solid has a definite shape and volume. In activity 4, the shape of a liquid water is examined, and in activity 5, the volume of water is measured. From these 2 activities, we find out that a liquid has a definite volume at constant temperature, but it takes the shape of the container. Thank you for listening. Please do exercises 1, 4, and 7 on pages 21 and 22 in your chemistry book. and don't forget to send them via email to be checked.